Hi, I'm Chris Robison, lead data scientist at Overstock, and I'm of course really excited to be here with you today. I'm going to share with you a journey at Overstock, as in the marketing department, we've taken some of the brightest minds in the industry and combined them with cutting-edge technologies to drive AI into every part of what we do. So let's get started. Retail is nearing the end of its digital transformation. Competition is more intense, and personalization is key. As we all fight over a smaller and smaller pool of new domestic customers, the existing customers are more sophisticated than ever, and their expectations are higher than we could ever imagine. If you don't know your customer and speak directly to her, you will lose. But at Overstock, we've never shied away from a competitive landscape. We've been pushing the boundaries of e-commerce since 1999. And what started as a large online rug retailer is now selling more than 5 million products to 160 countries worldwide. But the important part for me, as a data scientist and a hobbyist data engineer, is the nearly 20 years worth of e-commerce data. That means that I can actually go back in our weblogs and see young couples who in the early 2000s were buying a first set of bedroom furniture for their new toddler, and are today buying the first set of dorm room furniture for an excited new college student. And that's truly an incredible data set to mine, and Overstock has been with them there for every step along that journey. So after doing a very ruthless self-audit, we realized that we needed a new marketing architecture to actually unleash our very rich data and help us to personalize across silos. So where did we start? We had a fairly standard data infrastructure with lots of structured data flowing into our large relational databases that are Teradata or Oracle databases. These are being hit hard by our analysts with ad hoc SQL queries, as well as thousands of scheduled ETL jobs on any given day. We then had a newer HDFS infrastructure that was ingesting that really rich log data and trying to be hit by the data scientists as we were building out feature sets and trying to build out data pipelines. The problem was the teams and the two data infrastructures were still fairly siloed. So we had large ETL jobs moving structured data into HDFS and trying to join semi-structured data with financial records. And it was a hodgepodge of scoop jobs and Uzi flows. So we realized that we needed an infrastructure where we could push and pull data to and from where we wanted. And it had to support both batch and streaming contexts. So what we arrived at is what I'd like to call the water cycle of data flow. We have our N+1 data sources up on top. This is all of our internal financial data. It could be external demographic data from our third-party partners, census data. In the batch setting, we use Apache NiFi for our data movement. We can push and pull data as we need and ingest it into Snowflake, our large cloud-based data warehouse, where we can utilize Snowflake's separation of storage and compute to do massive joins across disparate data sets and start the featurization process. We can then push semi-featurized or hydrated data sets into Databricks, where we can utilize Apache Spark and the myriad of different technologies there to do modeling, to do advanced analytics, to push out the insights that our business partners actually need when they need them. We can then serve those results into mParticle, which is our customer data platform, or a low-latency Redis cache to be served up to the production site. And the cycle doesn't just stop there. We can then take the results of those machine learning attributes or propensities and tie them back to financial data in Snowflake so that we're able to speak to the bottom line effect and the KPIs that our business partners actually care about. In the streaming context, we're of course utilizing Amazon Kinesis heavily to stream data to and from all of our environments. And how many people here have set up a Kinesis stream? It's surprisingly easy. It takes about 5 minutes, and I generally spend 4 of those minutes trying to decide what to name the thing. We can then use Lambda and Firehose to start rolling up data, trigger event triggers that we can push back to our ops teams into the site. And again, we ingest those into mParticle and Redis, and the cycle starts over again. What this has allowed us to do is achieve comprehensive cross-channel marketing, all powered by AI built on Databricks. But what about the end customer? How does it affect them? Each of these 6 experiences can be generated for relatively the same customer in the same batch of search terms, depending on what they want to see and where they are in their buying cycle. So if they're looking for inspiration, we can show them the right content for that. If they're looking to explore, we can serve that content. Or if they know exactly what they want, maybe they have dimensions, a color, even a SKU, we can serve that up in a palatable fashion. Or maybe they just want to see what trending items are. What are the leading products for any taxonomy and category? We can give that to them. So let's get down to some facts. Why Apache Spark on Databricks? The support for Python and R are more robust in Databricks than almost any environment I've ever interacted with. This means that as my data scientists come out of academia, they have the tools at their disposal that they're comfortable using. As analysts come to us, they can use SQL context, they can use R, and they have a full suite of libraries that are interchangeable and easy to use. This means I'm no longer filling out JIRA tickets and waiting for software to be installed on on-prem stacks. We instantiate new libraries, and if they don't work, we delete that cell of the notebook and pretend like it never happened. More importantly, the collaboration tools are really rich. This means that my remote employees feel connected with the team on-prem in Utah. They can log in, we can collaborate on notebooks, we can roll back changes. We can use the education materials to make sure that we're onboarding people as quickly as possible so that they can add value on day 1, not day 14. And the full suite of technology, from ETL all the way to deep learning, means that every individual in this process has the tools they're comfortable with and can push technology and innovate together as a team. And really, this has allowed us to democratize the power of Spark across our entire organization. That means the right tool for the right person, whether they're a data scientist, a data analyst, an engineer, or a business owner. And I'm very proud to say, even our business owners are dangerous in a SQL context. So what about that human aspect? What we've been able to do are break down these silos, where we had business owners operating in spreadsheets, analysts doing ad hoc SQL queries, chasing down increasingly larger fires as we get closer to Black Friday, data scientists that are working in a myriad of different technologies, on isolated machines, on isolated VMs, not sharing code, not collaborating. And most important, none of these three were talking to our fantastic engineers, the fine men and women with decades of experience that can actually help us stand up hardened pipelines and write enterprise-grade software. So with the Databricks Unified Analytics Platform, we're able to move from silos to unification, where business owners, analysts, data scientists, and engineers are all working embedded in teams together, striving towards a common goal, trying to deliver actionable insights when the business actually needs them. And a more collaborative approach to data science and analytics has led us towards personalized marketing. This means audience and customer data flowing around in real time, where the different parts of the business need it, and a streaming infrastructure that gives real-time diagnostics and analysis. That means our analysts can answer questions as they come up, not a day late, not a dollar short. What this really means is we've enabled our business owners to get out of the spreadsheets and do what they do best, leveraging their domain knowledge and operating strategically to drive the business forward. And our parallel innovation has led to shared success at an unprecedented speed. We have closed the gap between POC and production. We've decreased the cost of moving models to production by nearly half, and we can stand up new models in 1/5 the time previously required. Most important to me as a data scientist and a manager, we can actually make inter-day improvements and iterate on our models. This means that there's no break in the creative cycle for my analysts or my data scientists. As they come up with new ideas, they're able to implement them. We can clone jobs or clone notebooks, and you can stand up the new infrastructure in real time and see how it behaves. And this is all built on the ability to quickly spin up and down clusters through self-service and cluster management. So we're only paying for the resources we need, but we have essentially infinite resources in our busiest times of year, which allows us to really innovate and push. For me, this means that when my VP comes to me and needs some insights or needs a chunk of analysis, I'm no longer thinking, oh, well, when will I have the resources to be able to schedule this very complex job? I simply ask them, when would you like the results? And then I smile and nod and say, yeah, we can make that happen. So it's the right people all working on a unified platform towards personalized marketing in real time. Overstock is setting the bar for marketing architecture. We're able to see trends as they unfold, and we're able to show her just what she wants when she wants to see it. So stay tuned, because you won't believe what we're about to do next. And I'd be remiss if I didn't invite you to come see our talk in 5 minutes. Michael Finger and I, our software director, are going to dive into the details in this journey from batch to real time, and we'll talk about enterprise data science engineering. Thank you.